For example 2, we are still finding operations on functions, but we're also going to find the domain of each problem. So here we have f plus g of x, which means f of x plus g of x. You're just going to add your two functions together with a plus sign in the middle. F is x squared minus 4, and I'm going to add that to x plus 2, which is g of x. And then I have something to simplify. I have x squared plus x, and then I need to take my negative 4 minus 4 and add it to 2 to get negative 2, and then we're done. Now the domain of our new function f plus g of x is going to be the intersection of the domains of the original two functions, except if you have f divided by g of x, and g of x is now in the denominator of a fraction, you do have to figure out what makes that 0. But in this case, our domain is just the intersection of the domains of f and g, and the domain of f of x is all real numbers, or negative infinity to infinity, and that's the same thing for g of x. So they completely overlap each other everywhere, and the domain of f plus g of x is all real numbers, or negative infinity to infinity. Okay, so now we have f minus g of x, which is just f of x minus g of x. And our f of x function is x squared minus 4. We're going to subtract g of x, which is x plus 2. And you have to be careful when you subtract your functions. You want to make sure that you subtract the entire function all the way through. And so I'm going to put some parentheses around my g of x function, or brackets, same difference, so that I can distribute my negative sign or my minus sign throughout the whole entire function. If I did not have brackets or parentheses around my g of x function, I would only be subtracting the first term x, and I want to make sure I subtract the whole thing. So now I have x squared minus 4. I'm going to distribute my negative. I get negative x minus 2, and then I get to combine like terms once again. I'm going to bring down my x squared and my minus x because there's no like terms for either one of those. And I'm going to put together negative 4 minus 2 to get negative 6. And the domain of f minus g of x is the intersection of the domains of the original functions, and the intersection for each of my original functions is going to be, once again, negative infinity to infinity. Once you find the domain for f plus g, it's going to be the same for minus g and times g as well. It's just straight up the intersection of the domains of the original functions. The only time you have to do anything extra is if you create a fraction. You have to figure out what makes your denominator equal to 0 and take that out of that overlapping domain of the originals. Okay, so now we have f times g of x, which is f of x times g of x. And my f of x function is x squared minus 4, and my g of x function is x plus 2. I need parentheses around each function so that I show that I'm multiplying the entire functions together and not just the two middle terms. You can't just put like a dot or a time symbol in between. And now I have a FOIL problem. So I'm going to multiply x squared by x to get x cubed. I'm going to multiply x squared by 2 to get plus 2x squared. I'm going to multiply negative 4 by x to get negative 4x. And then I'm going to multiply negative 4 by 2 to get negative 8. And that is my new function. And once again, my domain is simply the intersection or the overlap of the original two domains, which we found way back in example 2a. It was negative infinity to infinity. Okay, we're going to continue on with D, E, and F, and I couldn't see my functions anymore when I scrolled down, so I took a little break and wrote those in, and now we'll continue. F divided by g of x is f of x over g of x, and that is equal to x squared minus 4 over x plus 2. And I can continue solving this or simplifying this because x squared minus 4 factors into the difference of squares of x plus 2, x minus 2, and then we have a common set of factors that cancel in the numerator and denominator. X plus 2 divided by x plus 2 is technically 1, and 1 times x minus 2 is just going to leave us with x minus 2. Now the domain is still the intersection of the original domains, which is negative infinity to infinity. The domain of f of x was r real. The domain of g of x was r real. The intersection was the entire number line, which is all real numbers, everything shaded in. However, we need to figure out what makes the denominator of our fraction equal to 0 and pull that out of the domain. It is a domain restriction, whatever makes this denominator 0. Even though I canceled it out, it still is a domain restriction, and you need to figure that out before you cancel like everything out. Or if you do cancel it like I did, go back and take care of that. Okay, so I'm figuring out what makes x plus 2 equal to 0. And I guess I'll just put the work in over here. Don't have a lot of space. I'm going to figure out what makes x plus 2 equal to 0. And when I solve, I get x equal negative 2. And technically, that is a domain restriction. That is what x cannot equal, because if I substitute that value in, I get 0 in the denominator of my fraction. Okay, so I'm going to pull away or take out that negative 2 out of my domain of all real numbers. And then my domain of f divided by g of x is the intersection of all real numbers except for negative 2. And that goes from, I wanted to change color, but I didn't. I'll just leave it blue. And that goes from negative infinity up to negative 2, and then from negative 2 to infinity, not including the negative 2. So negative infinity to negative 2, union with negative 2 to infinity. Okay, my next part of the example is E is just switching those fractions or switching the fraction, and that's g of x divided by f of x. And g of x is x plus 2. F of x is now going to be in the denominator. That is x squared minus 4. And once again, we're going to clean up our new function by factoring the denominator into difference of squares. That's x plus 2, x minus 2. And we're going to get to cancel out a set of factors between my numerator and my denominator that they have in common. X plus 2 divided by x plus 2 is technically 1. Anything divided by itself is 1. And then we'll write that final simplified answer as 1 over x minus 2. Now, even though we canceled some factors out, you still have to go way back to your original function that you created, your original fraction that you created, and figure out where that denominator is equal to 0. I need to figure out where x squared minus 4 is equal to 0. Not the one down that I have left in the end when I simplified my expression, but way up here. Find out what makes f of x equal to 0. Okay, so I'm going to do x squared minus 4 set equal to 0. And I'm just going to use the square root method to solve. I'm going to add 4. I'm going to square root both sides. and then I get x is equal to plus or minus 2, but technically that's what x cannot equal because those two numbers make your denominator way up here equal to 0. And so our domain for g divided by f of x is the original overlapping domain, the intersection of the original domain, which was all real numbers, except we're going to take away -2 and 2. Okay, so our domain of g divided by f, my pen's not cooperating, goes from -infinity up until -2, union with the middle interval here of -2 to 2, union with the right side of 2 to infinity. The pen is not cooperating, and I don't want to start this video over, so I'm going to give this one last shot and see if I can get through f. F of x times f of x is x squared minus 4 times x squared minus 4. And we'll FOIL that out to get x to the 4th minus 4x squared minus another 4x squared plus 16. And that is equal to x to the 4th minus 8x squared when we combine like terms plus 16, and that's it. And then the domain of f times f is the intersection of the original function's domains, and f is intersecting itself, so that's just all real numbers. So you go from -infinity to infinity.